Good morning students and welcome to online teaching session. Today I am going to teach true solutions, suspensions, colloids. With this I am going to start today's class, and this is part of surface chemistry. So in continuation to the topics taught in the previous class. So first let us see what are called true solutions. Let us see with example. Best example for true solution is sugar solution, sodium chloride solution, etc. The particles of this solution are less than 1 nanometer size. And the other important property of true solutions is when we pour these solutions on the filter paper, entire true solution will pass through filter paper. Means in sugar solution, sugar particles will not be retained. In sodium chloride solution, sodium chloride particles will not be retained. Understood? That means particles are very, very small in size. That is less than 1 nanometer. Okay. Now we will move to suspension. In the case of suspension, particles size when compared to the particles of true solution, the particle size of suspension are very, very big. That is greater than 1000 nanometers. Right. In the case of suspension, best example for this is sand plus water. This is best example for suspension. And all the sand particles, once we add to water and stir that mixture, after a while, all the particles of suspension get settled to the bottom part of the container. And sizes of particles of suspension is greater than 1000 nanometers. Sizes of particles greater than 1000 nanometers. In the case of true solution, it is less than 1 nanometer. Now we will move to colloids. In the case of colloids, particles are bigger than the particles of true solution and smaller than the particles of suspension. So we can say colloids are intermediates. Of true solutions and suspensions. And sizes of particles in the case of colloids, sizes of particles lie in between 1 to 1000 nanometers. Right? Next, true solution is homogeneous mixture. True solution. It is homogeneous mixture. Suspension is heterogeneous mixture. It is. Because in the case of suspension, we can see water and sand clearly. And when we move to colloids, apparently the colloid look like homogeneous mixture. Best example, milk is a colloidal solution. So milk looks like homogeneous mixture. But when milk is seen under the powerful microscope, the lipid material present in the milk can be seen separately. So that way it is heterogeneous mixture. So without the help of microscope, with naked eye, colloids look like homogeneous mixture. But with the help of microscope, it looks like heterogeneous mixture because liquid material in dissolved condition can be seen. So this is homogeneous mixture for naked eyes. Naked eyes means without taking the help of microscope when it is seen. Next, it can be heterogeneous mixture with the help of microscope. Because the liquid fat that is present in the milk can be seen. So that's about true solution, suspension and colloids. Yes, children. Now let us see bifurcation of colloids on the basis of attraction between the particles. So classification of colloids based on interaction between the particles. So colloids means those substances wherein the sizes of particles lie between 1 to 1000 nanometers. Right? And these colloids mainly will have two media or two phases. Here phases means media. And what are those phases? They are number one, dispersed phase or medium. Second one is dispersion phase or dispersion medium. And this dispersion phase of the colloid is comparable to solute of the binary solution. And dispersion phase is comparable to solvent of the binary solution. Right? So whenever I refer particles, whenever particles are referred to, it means the particles of the dispersion medium or dispersion phase, but not dispersion phase. And here, how the particles are both the media going to interact with each other. Here interaction between the particles means whether they are going to attract each other or whether they are going to repel each other. So based on this interaction, we have two types of colloids. What are those two types? Let us see. First type of colloid wherein particles attract each other is known as lyophilic colloid, or it can also be called as lyophilic salt. And second type is lyophobic salt. So based on interactions, we have two types of colloids. Here interaction means it can be attraction or repulsion. And those two types are, number one, lyophilic colloid or lyophilic salt, and number two, lyophobic salt or lyophobic colloid. Now let us see what are called lyophilic colloid. Lyophilic colloids are liquid loving colloids. That means here interaction means attraction, right? So both the phases means dispersion and dispersion phases which are there in lyophilic colloid, they attract each other, and that attraction is nothing but interaction, right? And best example for lyophilic colloid is gum salt. Gum salt or gum colloid. In this, gum can be taken in the form of crystals or liquid. To that, when dispersion medium is added, we will get lyophilic colloid. So gum plus dispersion medium gives rise to gum salt. This is the best example. In between the particles of the gum and the particles of the dispersion medium, there will be attraction, right? And that leads to the formation of gum salt. So here attraction is there between these two phases. Now let us see the salient features of lyophilic colloids. These lyophilic colloids are reversible in nature. Now what is meant by a reversible nature of lyophilic colloid? Let us see. In lyophilic colloid we have dispersion medium plus dispersion medium, right? Let us see explanatory part of reversible nature. Dispersion medium plus dispersion medium. Now what I am going to do is, I will take this lyophilic salt and I will evaporate. Right? This on evaporation, dispersion medium is isolated, separated. As a result, we will get dispersion medium. Dispersion medium is removed by evaporation process. Now we got dispersion medium. If you take that dispersion medium separately in pure form, and to that again if you add dispersion medium, then we will get neophilic salt. So in this way we can separate one of the component of the neophilic salt by evaporation, and thereafter if we add the dispersion medium to so formed dispersion medium, again we will get back neophilic salt. So in that way neophilic salts are reversible in nature. That is one of the salient features of neophilic colloids. Next important salient feature of neophilic colloid is stability. They are stable. Means when neophilic salt is taken in a container and when it is stirred, when it is heated, and when small amount of electrolyte is added, nothing will happen. Neophilic salt will exist as neophilic salt only. Dispersion medium cannot be separated. Right? Just by warming, by shaking, and by adding small amount of electrolyte. The components present in it cannot be separated, or dispersion medium cannot be made settled at the bottom part of the container. So in that way, neophilic salt or neophilic colloid is said to be stable. Now we will move to the second type. Second type of colloid, that is neophobic colloid. Phobia means fear. Another meaning is repulsion. In the case of neophilic colloid, in between the two phases attraction is there. And here in neophobic colloid, in between the two phases repulsion is there. So phobia means fear or repulsion. In this case also we have two phases. Right? Both the phases will repel each other. So they can be called as liquid heating colloids. Means both the phases repel or hate each other. Means there is no attraction between them. That is the meaning. Now let us see how is it formed. If you take dispersion medium and to that if we add dispersion medium, we will not get neophobic colloid easily, but by special methods we can get neophobic colloid by special methods to get neophobic colloid. So here these two phases may be heated in order to make the particles of both the media come close to each other, thereby to form neophobic colloid. Right? If you take starch colloidal solution that is there in practicals, to make that starch powder we will take and we will make it paste by adding small amount of dispersion medium, that is water, distilled water, and then that mixture is heated. Thereafter it is filtered. Okay. Now let us see the salient features. First salient feature of neophobic colloid is they are irreversible in nature. Means the two phases of leophobic colloid can be separated by adding electrolyte. Once they are separated, again it is not that easy to make leophobic colloid by adding dispersion medium. In that way it is irreversible. And unlike leophilic colloid, leophobic colloids are unstable. They are not stable. Means, say, we have taken 100 ml of leophobic colloid. To that, few drops of electrolyte if we add, and immediately the particles of the dispersive medium gets concentrated or aggregated to form the heap of the particles. In that way, the dispersive medium can be isolated, separated from dispersion medium. That's why leophobic colloids are said to be unstable colloids. So that's about classification of colloids based on interaction between the particles. Now let us see classification based on nature of particles. Nature of particles. Here mainly we have two types of colloids based on the nature of the particles. What are those two types? Let us see. They are, number one, macromolecular colloids and then micromolecular colloids. These are the two types. Number one, first let us see the first type of colloid, that is macromolecular. In macromolecular we have particles of very big size. Right, and those particles may be existing in the nature or they may be synthetic, means man-made, one type. And second type of colloids are multimolecular colloids. Multi-particle or multimolecular colloids. Multi means many. So multimolecular and then macromolecular. First let us see multimolecular colloids. Multi means many. When a particular colloid is subjected to dissolution, here dissolution has two meanings. One meaning is act of solubility. Means when one phase is completely dissolved into the other phase, or when one medium is dissolved completely into the other medium, that is called dissolution. Number one. Number two, act of isolation is also called dissolution. Now let us see when a multimolecular colloid is subjected to dissolution, what we are going to get. So multimolecular colloid we have taken and it is subjected to dissolution. When it is subjected to dissolution, we may get large number of atoms. in aggregation. Next, sometimes that colloid, when dissoluted or subjected to dissolution, it gives rise to many molecules in aggregation. So we may get either atoms in aggregation in group or maybe molecules in aggregation. So such phenomenon wherein the atoms or the molecules are obtained in aggregation are known as multimolecular colloids. Again, sizes of particles of these colloids lie within the range of 1 nanometer to 1000 nanometers. Right? So dissolution means act of what do you call separation. One meaning, other meaning is act of solubility. So to such colloid we need to add dispersion medium. So when dispersion medium is added to such colloid, that colloid undergoes dissolution to form atoms in aggregation or molecules in aggregation. So that phenomenon is said to be the multimolecular colloids formation. Okay, here in the case of multimolecular colloids we have examples like this. To the gold dispersion medium, if we add suitable dispersion medium, it results atoms in aggregation. Next example, if we take sulfur, sulfur is octatomic molecule. One molecule is made up of 8 atoms. To that, if we add suitable dispersion medium, then it gives rise to molecules in colloidal form. So this is also formed in aggregation only. Right? And these two are nothing but multimolecular colloids. In first case, atoms are resulted. In second case, molecules are resulted. Now, let us see children. If these multimolecular colloids, if we add yes, children. Now let us see the second type of colloids. And second type of colloids are macromolecular colloids. The name macro itself indicates. Macro means polymers, right? And the molecules of these macromolecular colloids are much bigger in size. Now let us see how these macromolecular colloids resulted and the different examples for macromolecular colloids. In this case, first we will take the colloid, and to that colloid we will add suitable dispersion medium. As a result, we will get macromolecular colloid. And these macromolecular colloids can be natural macromolecular colloids. We also have synthetic or man-made macromolecular colloids. Natural macromolecular colloids are proteins, cellulose, etc. Man-made macromolecular colloids are nylon, polythene, etc. So that's about the macromolecular colloids. And these macromolecular colloids are stable. Means even if you add small amount of electrolyte, these macromolecular colloids will not undergo any change. Means dispersion medium and dispersion medium will be there as it is. And here in these concepts you have come across aggregation. It means concentration, precipitation, coagulation. So any term can be used. All these terms means same. Next, in the case of lyophilic colloids, there we discussed about the dispersion and dispersion medium. In lyophilic colloids, if dispersion medium is water, then it is said to be hydrophilic salt. So that's about the two important terms that come across these colloids. So aggregation means concentration or precipitation, wherein the particles of dispersion medium will come close to each other to form the precipitate-like structure. And in the case of lyophilic colloids, if dispersion medium is water, then we call it as hydrophilic colloid or hydrophilic salt. Thank you, children.